Welcome to section 5.2. I've tried to stress it as I talk to students in our class and through Zoom and everything, and then also in these videos. But the skills that are going to be developed here or demonstrated here are really your critical thinking skills that are necessary for your success in calculus. So we're not really doing trig. We can think that we are, but what we're really doing is using algebra and then rewriting things based upon trig identities that we need to know. So um, if we look at what's written here, there is a warning. Techniques used to solve equations such as adding the same term to each side and multiplying each side by the same term. We're not solving equations. What we are doing at some point is to work from one side of the proof or one side of the equation until it matches the other side. Um, and so as you do that, it's inappropriate to already assume that the relationship's there and to build off of that. You won't see that in this initial one, but we're trying to prepare you for the future when we say, hey, show a particular identity. And so here we are, and let's look at a few examples that are found in the book, and we'll work through them together. So when you have something like this, where these denominators are almost the same but not quite the same, they're thinking you have a lot of experience with that by solving things back in Algebra 1 and Algebra 2 as this, that you would look at this and say, oh, I know what the common denominator is. I got a factor. So if you've totally forgotten about getting common denominators and other things like that in a rational expression, that's going to be a problem because they taught it twice and they're not going to teach it again. They're just expecting us to use it. And so here's what they expect us to remember, that you would see these guys as different from one another and no easy way to make one look like the other through multiplication. In fact, no way to do that. So then the common denominator would be each one. And so this one would have to multiply by that, and this one would be needed to multiply by the other, right? So it's 100% the same as this question from arithmetic, 1/5 minus 1/6. There's no easy way to make a 5 look like a 6 through multiplication, and so we just multiply by the other and get the common denominator 30. No difference whatsoever. So I'm not gonna waste your time doing algebra 1 type of work with this, but just that principle that if the denominators are completely different, then the common denominator is the product of the two. And so I'll just try to take this slow, but realize its root is in usually a chapter 6 in your beginning algebra book and also chapter 6 in your intermediate algebra book. So I'm just going to take a moment to rewrite this. Sine alpha minus 1. And I'm going to give myself some space here. 1 over sine alpha plus 1. That is its own term down there, or own, term that we have. And so what are we going to do? We're going to multiply top and bottom by sine alpha plus 1 for this first one, and sine alpha minus 1 to the second. So I'm going to try to show all the steps. That's what we would have. And so what's that look like? Up top we'd have sine alpha plus 1. Now take a look at the bottom. Sine alpha minus 1 times sine alpha plus 1. You know what that is. Sine alpha times, it's this. It's x minus 3 times x plus 3. Right? Something from pre-algebra days. X times x, x squared. My middle terms are going to cancel out, minus 9. Same thing. Sine alpha times sine alpha, sine squared alpha. Negative 1 times positive 1, minus 1. You know from your pre-algebra days that there's no need to do the full FOIL. You're welcome to, and you'll get a positive sine alpha and a minus sine alpha in the middle. But we think those days are well behind you. Shouldn't say behind you, but that you've done that work so much that you don't need too much other than somebody possibly pointing out, hey, look, it's that. So let me give a little bit of erasing here and we'll come back right up here. So look what we have. We have the exact same denominator. So let's keep that common denominator. And so far we've used no trig. So that's what I'm going to try to point out. So far everything is in the skill set that you brought with you to this class. In order to put two fractions together, we need a common denominator. In order to get that common denominator in an algebraic sense, you need to build it, and we did. We are using a pre-algebra principle that a minus b times a plus b is a squared minus b squared. Now we're still using arithmetic. Sine alpha plus 1 minus sine alpha minus 1. So actually we'll go to arithmetic, and we know that this is over this common denominator, sine squared alpha minus 1, since they match. We'd have a sine alpha plus 1 minus sine alpha. And then remember to distribute your minus to the other side, plus 1. So we're taking this minus in a pre-algebra principle of distributing it through. We're going to clean up the top. The top cleans up to be 2, right? The sine alphas go away. 1 plus 1 is 2. The bottom is just hanging out as sine alpha minus 1. So up until this point, the very last point, we are in a position where we've used no trig. None whatsoever. Now we need trig. Let's see what we remember. I'll write it down here. Hopefully you remember that sine squared alpha plus cosine squared alpha is equal to 1. We need to replace sine squared alpha minus 1, so let's get it by subtracting 1 to this side. And now we have sine squared alpha minus 1 just like we want. I'll go slow. Plus cosine squared alpha is equal to 0. So sine squared alpha minus 1, if I solve for it, I move the cosine squared over. That's our first trig that's needed, 2 over negative cosine squared alpha. Now why did we need that? Because they wanted no quotients. I still have a quotient, right? But you know what 1 over cosine? 1 over cosine is secant squared alpha. There's your answer. 2 secant squared alpha. That nicely. So you use the trig at the very end. Very representative of calculus, except almost in reverse. The calculus is done first, and then it's a huge algebraic cleanup in the end. It's typically the algebra that causes problems. Now take a look at what they're asking you to do here. Factor each trig expression and simplify as much as possible. Now this isn't my direction, right? I'm not making these problems up. This is number 16 and number 18. They want you to practice with factoring. Should be no different than these right up here, right, that we looked at last time in the last video. We really have this one right here for the first one. We have a difference of 2 perfect squares. We know how to factor that. If we have a difference of 2 perfect squares, it's the first one, tangent x plus cotangent x, minus the second one, tangent x. Well, I got to be careful here. So it's the first one minus the second one, times the first one plus the second one. Don't need to be as careful here, but I'll have the same notation. So they're making sure that you are a good algebra student, right? As well they should, because that's your success in the other classes. Let's take a look at the first parenthesis. Let's distribute that negative. We have tangent x plus cotangent x minus, let me make that more pronounced since we can. So here's this negative sign going through. Here's the negative. Let's make it go through minus tangent x. And if it goes through again, plus cotangent. Whoops, let me go and erase that and put that in black. Right? So it's that plus that I was worried about. We needed to pick that up. And then over here, tan x plus cotan x, nothing happened to that. And a plus 1 adjusting the other one, tan x minus cotan x. Almost finished. Take a look at the first bracket. The tangents go away. The 2 cosines come together. Or 2 cotangents, sorry. 2 cotangents come together. And then if we look at the second one, the cotangents go away and the 2 tangents come together. So now we have 2 times 2. I know what that is. That's 4. And we have cotangent times tangent. So at this point, we've used absolutely no trig. What happened first was a difference of 2 squares, no different than how you factor a squared minus b squared. A minus b times a plus b, right? A minus b times a plus b. And this is the majors that you chose, right? Ones that would be very analytical. Then we've done nothing more than combine like terms, right? As we have in pre-algebra days. Here we are. We know that 2 times 2 is 4, and cotangent times tangent, they're not the same, so we just write them. But we do know now, right, that one's the same as we do know the trig relationships between the two, that cotangent is 1 over tan x times tan x. So where are we? We're back in arithmetic. The same thing on the top and bottom. The answer for that one is just 4. So the answer for this first number 16 is 4. So in order to explain it all, I needed to use that whole screen there so it bled over into the 18 space. But they are expecting us to remember how to factor. So I'm going to go ahead and erase this so that we can do the next problem. But you can see that I'm using no trig until the very, very end. So if you say, oh my goodness, this is so hard, like with these problems, most likely the difficulty is the skill set you're bringing with you, right? As opposed to anything else. It's that skill set you're bringing with you. So for example, when we look at this next one, it should be no different than solving this from both beginning and intermediate algebra. 4x squared plus x minus 3. We know how to factor that. Now our x's are just tangents, so factors of 12 that subtracted be 1 are 4 and 3. So it's going to factor as a 4 tangent. Tangent's my x, beta, and a tangent beta. I need to get a 4 out, so the 1 needs to go here and the 3 needs to go there. My 4 better be positive and a minus. So we're hoping the only thing that happened here is being able to factor this guy. Hey, this is a 4x and an x. This, I need to get a 4 and a 3 out. The 4 needs to be positive, 3 needs to be negative. The tangent is just your new variable, right? Tangent of beta is a variable. It's nothing different than that. So that's how you want to think about these guys. Algebra first. Done. That doesn't simplify at all. There's no way to simplify 4 tangent beta minus 3 or tangent beta plus 1. This one, they're wanting to make sure that you know how to do the sums and differences of cubes. So if you went through Algebra 2 and you didn't memorize that, please know it's going to be an expectation. This wasn't made up. This is number 22. This isn't Jensen and his friend saying, what can we give to mess them up? This is a practical problem that has uses later on. So hopefully you remember that x cubed plus y cubed factors as x plus y times x squared minus xy plus y squared, right? Square multiply square. If you had me in Algebra 2, that's what we would talk about. But that's it. Your x's are sines, your cosines are y's. So you walk in with that, and then it's easy. Sine alpha plus cosine alpha. Square, sine squared alpha. Switch the sign and multiply. Sine alpha cosine alpha. And then square. Now we would be done if there were no trig to do, but there's some trig to do. So back here there was nothing. There's nothing to do with tan beta minus 3 and tan beta plus 1. If you multiply it out, you're just going to get what you started with, and they wanted you to factor it. This is factored, but the question is, can it clean up? Absolutely, because you know what sine squared plus cosine squared is. What's sine squared plus cosine squared? Ideally, you'll have it memorized. Be careful if you're having to look it up. 1 minus sine alpha cosine alpha. Done. Don't think there's anything to do there. That doesn't change into tangent or anything else. But there we go. We do as much as we can. So I'm going to erase this so that we can do part D. Now part D doesn't have a number associated with it, so it may be something that we made up in the spirit of what was there. So I'm going to give us a little bit more room, just coming over here. Okay, what do we have? We have 4 terms. So this is nothing different than 3x cubed plus 15x squared minus 12x minus 60. How did you do that back in Algebra 1? That would be the first place that you saw it. You might have even seen it in pre-algebra. It just depends. You'd factor by grouping. Pull the 3x out and be left 3x squared and be left with x plus 5. Pull the negative 12 out and be left with the same x plus 5. So that is an Algebra 1 skill that we think you still have. Well, your x's are just cotangents. So we're going to pull out the 3 cotangent squared x and be left with cotangent x. Apologize. I don't know why I hesitated. Plus 5. And then we're going to pull out the minus 12 and be left with the cotangent x, also plus 5. Right? We're well versed at why that 5 is now positive. If you distribute the 12, you'll get your negative 60. Where was that well versed in? Algebra 1. So I'm mentioning that so that you understand where your problems are. If you're saying, I don't know how to do that first step, no, trig is not your problem. Math 335 is not your problem. It's the foundation that you thought you had developed. We need it to be stronger. Then we would say, okay, this is 3 cotangent squared x minus 12 times the common cotangent x plus 5. Now the algebra is done. Actually, that's not true. Algebra would have us do one more step, and I apologize for not seeing that. Actually, 2 more steps now that I see it. Still algebra. To pull out the common 3. And so we could have seen that in the very beginning. That might have drove somebody nuts. We could have pulled out the 3 from the very beginning. I didn't see it at first. No problem. Because I see it now. Right? So how about this cotangent squared minus 4? That's no different than x squared minus 4. You know how to factor that. So still more algebra. Cotangent x minus 2. Cotangent x plus 2 times cotangent x plus 5. In this problem, there was no trig needed. Everything was just algebra. Because as I'm looking at that, none of those parentheses can simplify using trig. I could rewrite them as cosine over sine, but that's not simplification. That doesn't lead me to anything. If I multiply them together, then I'm going to get right back to the beginning. So that's not wise. This is the factored form and completely factored. And so it is nothing more than a problem just like this guy up here that we had in Algebra 1. First section of the factoring chapter, factor by grouping, which laid the groundwork for the rest. So I'm going to stop this video and we'll do more of 5.2 and as we go along. So I'll probably make it into at least 2 parts.